Okay, I think we're ready to add and subtract like Radicands. Okay, so let's look. I have square root of 3 plus square root of 3. I'm asking you to do addition. The rule is the rule. It hasn't changed since kindergarten. To add or subtract, you need like terms. In radical world, the radicands have to be identical. And they are. They're both square roots of 3. Now, when you're adding the coefficients. Well, you're going to say, I don't see the coefficients, Miss Black. That's okay. They're understood to be the numbers 1, just like they would be in front of a variable. We write in algebra x, but we understand there's a 1 in front because it's connected by multiplication. And 1 times any term is itself. So now I can add 1 square root of 3 plus 1 square root of 3 means I have 2 of these square roots 3. The term that's alike when you add stays the same. When you add 1x and 1x, you get 2x. The x doesn't change when you add. It stays the same. All right, let's go to our next expression. Negative 8 cube roots 2 minus 1 minus cube root 2. We have here 3 terms, 1, 2, 3, 3 monomials. I'm asking you to obviously do subtraction. So I'm looking for terms that are alike. Are all 3 terms alike? Nope. This term has a cube root 2. This term has a cube root 2. So these are your like terms. These are the terms we can put together. The radicands are identical. To add or subtract, we're going to look at the coefficients and make a decision. This coefficient is negative 8, and this coefficient is negative 1. Well, if both coefficients are negative, we know we add. So a negative 8 and a negative 1 would be a negative 9 cube roots 2. Now we have this other term, minus 1. It's a whole number. We cannot take a whole number and add it or subtract it to a radical because they're not alike. So we would write minus 1. Now let's talk a minute. If we were back in polynomial world, we would write negative 9x minus 1. I agree with that. We would put the constant at the end. We always like our variables first and our constants at the end. But in radical world, we do not like our constant at the end because then we get confused. Is that negative 1 underneath the square root symbol or not? So in radical world, when we have a constant, it will go in the very front of our expression. So even though this is the correct answer, it's not written in correct form. The correct form is the whole number should go in front, negative 1, and then the radical, minus 9 cube roots 2. And that is proper form in algebra. In radical world, we like our constant in front so we have no confusion. We know that's not part of the radical, the root. All right, our last expression, 5 square roots 12 plus 3 square roots of 12. I'm asking you to add. Are our radicands the same? Yes, they're both square roots of 12, so we can add. If I have 5 and you have 3, we add it up, we get 8 square roots 12. Is that our final answer? No. Because if you look here, 12 is not reduced. Now, go back here. 3 is reduced. 3 is a prime number, and it's not a perfect square. It is in lowest terms. If you look here, this says the cube root of 2. 2 is not a perfect cube, and it's prime, so it's reduced. But here's our problem. 12, I agree, is not a perfect square. But 12 has a perfect square in it. What number on the perfect square list divides into 12? You're right, it's 4. So this is not acceptable because we could write 12 as 4 times 3. And now let's simplify. We'll leave our whole number 8. We know the square root of 4 is 2, so that's why a 2 comes out, connected by multiplication. We have a square root of 3. 3 is not a perfect square, and it's prime, so it's in lowest terms. It can't be reduced. We leave it. 8 times 2 is 16 square root 3. So the moral of the story is, after you do the operation addition and subtraction, make sure what's underneath the radical cannot be reduced. If it can, you must reduce it. Your answer must be in lowest terms. Great. See you in the next module.